Happy Wednesday. I think we pretty much finished strings on Monday, right? So we're going to talk about the lab. So I think a lot of folks got stuck on the decrypt part of the lab. That's okay. All right, we'll talk through it, see if we can make some sense of it, get that solved, and then we'll start on lists. We got all next week for lists and dictionaries, but we can at least get started on it. So we've got something to do today, more than just the lab. So let me fire up PyCharm here and trying to remember if I even committed that to the repository or not. I don't remember. Let me take a look at my GitHub here. For one. All right, let's see. What did I do last? Just the strings chapter. I thought I started encrypt in class, didn't or in the lab, didn't I? I thought I did. Wonder if I put it somewhere else. Yeah, let me see. Let me see if I have it in here. Okay. Lab 0. I updated that one last week. Now it's 150. Lab 0's last one. Do I not have it? All right. I don't remember if I had it or not, so that's fine. Start up a new project. Probably just left it in the lab, didn't I? It's my bad. That was lab 3, right? I think lab number 3. Let's take a look. Yeah, for strings. Okay. So encrypt was pretty quick. That was just doing some slicing for us. The decrypt was the harder part, right? So define encrypt, given some message to encrypt, and then a stride. Again, if you wanted to default stride, cool. If you didn't want to default it, that's okay. Um, Either was going to be fine. This way, you don't have to give it a stride if you just want the letter shifting, right? And maybe that makes it slightly easier to use, I guess. So the first part, right, we need to take the slice of it here. So we're going to have the encrypted message, right? There's going to be an empty string to start, and then we're going to loop through for every stride, right? So then for, I don't know, starting index and range stride, right? So if I'm going to do 3 chunks, right, I need to start at index 0, index 1, and then at index 2. So I'll get those 3 different chunks here. So take my encrypted message, then I can add to it the message. Now I want to start at the starting index, right? I want to go all the way to the end, and I want to stride by the stride. Right? So the end is optional. I want to start at the first time 0, and then if the stride was 3, take every third character. And then the loop goes back. Now index is 1, so I'm just going to start at index 1, take every third character. Index 2, take every third character. So that'll go through, yeah. That's how many characters we skip. So if it's defaults to 1, so you take every character. If it's 2, you take every other character. If it's 3, you take every third character. So it's like how far it's going each iteration. Yep. All right, once that's done, then we're going to go and shift them, right? Then take its ordinal value, get the index position, convert it back to a character. Then, so for, uh, I guess this is not really the encrypted message. This is the chunks. I don't know. That's fine. Uh, we'll call this the sliced sliced message. Is that now I can say for character in sliced message, I want to do something here. And then I need also the new, like, now this will be the encrypted message is an empty string for every character in the slice message, but really I need the character and I need the index, right? So maybe I just do for index in range length of the sliced message, right? Now I can take my encrypted message and I'm going to add to it the sliced message at the index, right? I'm going to take the ordinal value of that, and then I'm going to add the index to it. I'm going to turn all of that into a character, right? Get the ordinal value, add the index, turn it back into a character. I think we did this in the lab, right? I think I had this shown. When that's all done, then we can return the encrypted message. Right, so 2 steps: slice it into chunks, and then shift the characters based on their index. So if we were to print, we want to encrypt. I think we did like Happy Monday, right? Happy Monday. This was a little harder to follow. If we just do A B C D E F G H I J K, this might be a little easier to follow, right? Because I'm going to get the first letter and then the next letter, or no. So first, this is let's do, this is 11 characters long, right? So I'm going to get the first one and then the fifth one. Oh, I can't do my letters in the right order. D, E, F, G, right? So it'll be a chunk of four, a chunk of four, and then a chunk of three, right? If I take every third character, so A, and then skip to D, skip to G, skip to J, and then we go back to the beginning. B, skip to E, skip to H, skip to K, and then start at C. C, skip to F, skip to I, right? And then each of those then will get shifted. So we would expect that to be what A, we said skip to D, skip to G, skip to I, and then B, skip to E, skip to H, skip to K, and then C, skip to F, skip to I. That would be the next step, but then each of those is going to shift, right? So A won't shift at all. D will shift by one to an E. G will shift by two, G, H, I. I will shift three, I, J, K, L. B will shift four, C, D, E, F. And after that, I'm just giving up right now. That should be the start of it, right? So if we run this, we should get, oh, we were close. I was off by one, right? But my shift was wrong? Did I not shift? Oh, okay. Let's see. The sliced message. No, that was fine. All right. Maybe I'm off by something. So let's print the sliced message real quick. Sliced message. See what we get out of here. So we slice it. We should get a call encrypt. Is that not A, B, C, D, E, F, G, H, I, J, K? Is that the slice? Oh my goodness. I'm getting myself confused here. Give me 1 second. Comment that out. All right, so that should be a sliced message, but it's not sliced. Why didn't it get that sliced? That's the original. All right, let's put a breakpoint in. Let's run it in debug mode, see what's happening here. So our original message is here, and then we take a slice. Oh, I didn't give it a stride. That's my bad. Stride was 3. If the stride was 1, we take every letter. This will make a little bit more sense here now. Sorry. Okay, now we get the mixed up version. Okay. Now we should get, yeah, so A, D, G, J, B. Okay. We got the right version. Sorry about that. All right. Then, when that's done, right, if we print all of that, we should get this next encrypted version, essentially, right? Yeah. AEI. Okay, I just was off by 1 with the L. I just counted wrong. Wow, I hit insert. Where's my insert key even? That one? Okay. All right. You with me so far? So we encrypted. So to decrypt that, right, going back the other way. Now this is a little harder, right? So we need the message, we need the stride. I guess I should leave the encrypt part here, but that's fine. We need to first undo this shift, right? Because we're in reverse order here. So we have the, I don't know what the chunked message starts as nothing here. And then for index and range length of the message here, we're going to take the chunked message and we're going to add to it the message at the index, right? That as an ordinal value. Now we want to subtract the index from that, right? And turn that back into a character. So that should undo the shifting, right? Now we get back to our chunked version. Right, so if we return the chunked message, we should get back this version here. So if we encrypt, print encrypt of A, B, C, D, E, F, G, H, I, J, K, yeah. The what? This one? So I can add to it. So I can say this append equals, right? I'm just adding characters 1 character at a time because I don't have a place to put them right now. So as I do 1 letter at a time, I'm adding it back to this original one, which is terribly inefficient, but it's. I'm sorry? This one? It's whatever I pass to it, right? Whatever value is given, I'm going to call message inside this function. What? So I'm going to I'm going to save this one. So my encrypted message is equal to encrypt of this, right? Encrypted message. So whatever I get back from my encrypt function, I'm going to save, and then that now I can pass to decrypt. I can pass it that encrypted message, so it should be able to undo it. And I'm going to use print here, right? So we should be able to get back the chunked version of that. It should be what we had before. Oops, and the stride. I keep forgetting the stride. Stride. So stride is 1. That's going to kill me. Stride is 1. Oh, 3. All right. So we get back the chunked version, right? So this is where we got before we did the shifting, is what we had up here, right? So if we print out the sliced message again here, those ones should match, right? So I get the sliced version. So I've undone the shifting part here. Now, before we can return it, then we're going to have the original message. We'll have original message. We need to undo the chunking. Now, this is the hard part. To undo the chunk is a little weird. So we looked at a little bit of arithmetic in the lab, right? So we know that the chunk length is going to equal my length of the message integer division by the stride. Because that'll be a whole number rounded down. So if I give it 11 characters and I divide by 3, my answer will be 3. So I know each chunk is at least 3, right? The smallest chunk was 3. Some of the chunks might be bigger than 3. If I give it 9 characters, 9 divided by 3, exactly 3. Right? So this will be the smallest chunk size that we have here, the chunk length here. Then I need to know the remainder, right? The remainder is how many chunks have an extra character. So my remainder or something, remainder or extra characters, or I don't know what I'm going to call them here. Longer chunks is the length of my message modulus the stride. Right, that'll give me the remainder. So if I gave it 11 characters, I'll have a chunk length of 3 with a longer chunks, 2 longer chunks. Longer chunks equals 2. How about number of longer chunks? Look at that. We can use really nice variable names. So number of longer chunks will be 2. If I give it 9 characters, I'll have a chunk length of 3, and number of longer chunks will be 0. There are no longer chunks. They're all exactly 3 because it was evenly divisible. So I need those two numbers now to be able to unchunk it, right? Because the idea is I need to take the first letter of the first chunk, A, the first letter of the second chunk, B, the first letter of the third chunk, C. Then I go back. I take the second letter of the first chunk, the second letter of the second chunk, the second letter of the third chunk, and I go back, right? So kind of working our way through how do we put this back together here? Well, I need to do something stride number of times because that's how many chunks I have. Right? Stride is the number of chunks. If my stride was 4, I have 4 chunks. If my stride was 7, I have 7 chunks. If my stride was 2, I have 2 chunks. Right? So I'm going to say this will be my the starting index is equal to in range stride. This will be what the starting, or no, this will be the character index in chunk. How about that? So the character index in the chunk. So my range of stride. If my stride is 3, I'm going to get 0, and then I'll get 1, and then I'll get 2. Because I need the 0th index of this chunk, the 0th index of this chunk, the 0th index of this chunk. Right? And then I need the first index of this chunk, the first index of this chunk, the first index of this chunk. I need the second index of this chunk, the second index of this chunk, the second index of this chunk. Right? So this will go through each chunk, and I'll be able to grab the character index that I'm starting with. Right? So as I loop through and do that, I need a couple things. So I need to know which chunk number I'm at. So I'm going to say that my chunk number starts at 0. Right? So the first chunk is chunk 0, the next chunk is chunk 1, the next chunk is chunk 2. Right? I need to know which chunk I'm in. And then I need to know where I'm starting. So my index then is going to start at the character index in the chunk. Right? Now I'm going to use a while loop because I think this is easier here. So I'm going to say while my index is less than the length of the message, or chunked message, probably chunked message, right? Because we're going to use chunked message. Now I'm going to start taking characters, right? So I know I'm going to do this many times. So I'm going to take some characters now for each one of these, right? As I'm going to go for each character I need that many. Uh, no, in the range of stride, is that? No, this is chunk length. Sorry, in the range of my chunk length. So I know if there's 3 characters in my chunk, I know I have to start 3 times. So I'll get 3 characters. If I give it a 15 character message, my chunk length should be 5. I know I have to do this 5 times because I need to get 5 characters out of each chunk. Right? So I'm going to start with this one, and then while my index is less than that, I'm going to take my original message and I'm going to add to it my chunked message at the index. Right? Now we need to move to the next one. So I'm going to take my index and I'm going to add to it the chunk length. Chunk length. Right? Add the chunk length to it to jump that much further. Now the problem is some chunks are longer than others. So if my chunk number is less than the number of longer chunks, I'm going to take my index plus 1 extra. So if there was a remainder and my chunk number is less than that remainder, I need to add an extra letter, right? Because chunk length was 3 when I gave it 11 characters. I can't just go from here and jump 3, right? Because then I'll be at the J. That's incorrect. I know that this chunk is longer because it's less than the remainder. There was a remainder of 2, so 2 chunks are longer, right? So my chunk number, if it's one of the longer ones, needs an extra character, right? Then my chunk number goes up by 1 as well, right? Then I go back to the index. I've added the chunk length and maybe a 1. Let's go back. Am I less than? Is there more to go, right? Am I less than the length? Because as many chunks as there are, we're just going to keep adding the chunk length and possibly 1 if it's less than the remainder as we go. So if we run this in debug mode, and do this in debug mode, we should be able to watch it rebuild itself. So we get the chunked message is this version here, right? It's good so far. So we're going to start building out that original as we go. So I'm going to step here. So starting at chunk is 0. Index starts at my character in the chunk. So that's 0. 0 is less than the length of the message. Let's take the character at index 0. That's the first letter of the first chunk. And then we're going to add the chunk length. If this chunk has a remainder, right? If it's longer, then add an extra 1. And then we'll add the chunk number. So now index is 4. Is 4 less than the length? Yes, it is. Let's take the character at index 4. That's the B. Right? Now we'll add the chunk length to our index. Is the chunk number less than the number of longer chunks? Yes, it is. So let's add another 1. This chunk number 1, index 1, is longer. Add another character. Increase the chunk number. Now, is index less than the length? Yes, it is. Okay, so take the message at that value. Now we have ABC. Add to index. Is chunk number 2 less than the number of longer chunks? No, it's not. So we don't add an extra 1. Our chunk number goes up by 1. Now index is 11. Is 11 less than the length? No, it's not, because the length was 11. Now we're done. We got the first letter of each chunk. Now we go back and we're increasing now to the next letter because we're ranging through chunk length. So as many letters are as in each chunk, right? There were 3 letters. Now we're going to start at 1, right? Index starts at 1. So we're going to take the character to index 1. Now I got the D. Let's add the chunk length. If this chunk has an extra letter, add an extra 1. Keep on going, right? So this will get me through. Now I'm taking the third letter of each. That loop is done. But I'm still missing the 2 letters, right? The last 2. So I haven't done the last little bit. So I've got 3 letters out of each chunk. Now I have to deal with the remainder chunks. Right, so the last little bit then is going to say, okay, I need, we want to have, we'll say my index is equal to my chunk length. And we can say for remaining character in range of the number of longer chunks. Right? Whatever that remainder was, that number of longer chunks, I have that many more characters to take. Right? That's a remaining character, extra character, whatever you want to call them here. So starting at the chunk length index. So if chunk length was 3, start at index 3. That's the fourth character, right? That's the one I didn't grab because I already grabbed the first three. So starting here, we're going to take our original message. We'll add to it the index, right? We're going to return the original message. Then I'm going to take uh, my index. I'm going to add the chunk length to it plus one because I know I can't just add three because I know the next chunk might have an extra letter, right? So we're going to add four to jump four more characters. So you get the next remaining letter, and get the next remaining letter, and get the next remaining letter. So if the remainder is zero, this loop doesn't run at all. If the remainder is two, it runs twice. If the remainder is one, it runs once, right? If the remainder is seven, it will run seven times. Whatever that remainder is, that's how many letters I didn't get evenly out of all the other chunks. So we give that a run, we get our original back. So it just kind of it's puzzling through and going step by step by step. How do I undo this process? And it's not straightforward. I don't know if any of you tried ChatGPT. It was not able to undo this process. I tried a couple different prompts. I wasn't able to find the sweet spot. It gave me some code, and it's like this will work for you, and it didn't work at all, which was kind of funny, right? It had no idea. So there's still some thought that has to go into how do we do this, right? You can't just give it this and say how do you undo it because it doesn't work, right? I think I tried it. Was it GPT? Let me try it again real quick. How do you verse this function? I tried. Oh, I tried it in C++. We'll see if it's any better in Python. Had no luck getting it done in C++. Oh, okay. Let's try their decrypt. That one looks slightly more promising. We'll try. This is decrypt GPT. And the group size, the length plus the stride minus one divided by the stride. Ceiling division? That's floor division. It's common to even confusing here, right? When you do integer division, you're flooring, not ceiling. I'm a little confused by it here, but we'll try it. We'll try it. So let's try print decrypt GPT, given the encrypted message and a stride of 3. Do you think it's going to work? Did it work? GPT failed. Boo. Boo. We're still smarter than computers. Yeah. All right. That amuses me, I guess. I don't, maybe that's more depressing to you guys, but I find it amusing. So, like, it was more than happy to give us code. And it's like, oh, it might not work if it contained non-ASCII characters. No. Should work for typical ASCII text and reasonable stride and length. Nope. It does not. Slicing the message into parts with the indicated stride, incrementing the Unicode at its index, reversing the function, you have to perform the opposite. Decrement the Unicode, assemble the parts together with the corresponding stride. You can't just take the stride again, right? And that's the problem. It's trying to use the stride. It's saying, hey, take those parts together with your stride. You can't do that. It's not working there, right? You can't just you can't stride over it again to unchunk it. It's not reverse, right? So, and that's sort of like the reasoning here. You can't just do the same thing backwards. Right? You get a different result. That's all. So that's sort of the idea with this one. Playing around with it as more of a thought exercise. How do we step through these line by line by line and see, can we solve it in English? Because if you can't solve it in English, you have no hope of writing code to do it, right? Once you can solve it in English, then we have a chance. We can say, okay, now I can break it down to step by step by step. Even we had, okay, take the first letter of the first chunk, the first letter of the second chunk, the first letter of the third chunk. We solved it in English. Turning that into code was still a little tricky, right? Like, how do I get the right numbers? And how do I know if I'm adding an extra one or not, right? That's all the extra steps we had to figure out here, right? So this was meant to be a little tricky. I apologize. I don't think anyone finished it in lab. I had one person finish it in the C++ class out of the class of 30 people. So just meant to get you thinking, right, about how do we take problems and solve them, and use functions while we're doing it. Okay. When we're doing the original encrypting or when we're doing the decrypting piece. So when we decrypt, we know that the chunk length here is the length of my message floored divided by the stride. So if I give it 11 characters and my stride is 3, I know there's going to be 3 chunks because my stride was 3. And I know each chunk will have at least 3 characters because that's the division.
Right.
2 of them will have an extra character because there's a remainder. It doesn't divide evenly. Right? If I give it exactly 9 characters, then I get 3 chunks of 3. Super easy. There's no remainder. Life is good. So dealing with the remainder is the tricky part. So I know all of the chunks are at least this many characters long, and this many of them are longer by 1 character. That's what this arithmetic's doing here. Because that way, now I can go through and say, okay, I know ABCD is the first chunk, EFGH is the second chunk, and then IJK is the third chunk, right, as we break them up here.
And how do we know where the actual letter is?
So whatever the remainder was, I know that many chunks have an extra letter. So as we're doing it, I said, okay, this is chunk number 0 to start. The first chunk is chunk 0. The next chunk is chunk 1 and chunk 2 and chunk 3. So if we give it something even longer, right, we could give it the whole alphabet if we wanted. B, C, D, E, L, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So 26 characters with a stride of 3. 26 divided by 3, we're going to get 8 for 24. So I'm going to have 8 characters in each chunk, and there's 2 with a 9th character, because the remainder is 2. So let's go through and we'll print out the chunked message here for fun. So just so we can see what it is, right? We'll print chunked message. So that just chunked here, right, is going to be every third character of the alphabet. So A, D, G, J, M, P, S, V, Y is every third character. Then we start at the second character and take every third character. Then we get B, E, right? So we made this into 3 chunks. This one is 9 characters long. This one is 9 characters long. This one is 8 characters long, right? So then as I'm unchunking it, right, the same process happens here, right? For every character in the chunk length, I have to go grab a character. So if the chunk length is 8, I have to go grab 8 characters, starting with the first chunk and then the second chunk and the third chunk. So this loop here, we're not even like counting number of chunks. We're just going as long as we're less than the length. Because this made a little bit more sense to me here. So we're essentially saying just keep going to the next chunk by adding the chunk length. That'll go to the next one. And maybe it's plus 1 more because I know there's a remainder or not. So I think the encrypted message here is going to be kind of funny looking. Let's go find that one here. Where did encrypt? Did I not print it? Did I already get rid of print? Where did I have my prints? Oh, okay, I printed it here when I was solving it in the chunk message. That's where it was. Sure. So interestingly, is that this is the chat GPT decrypted is the same as the chunked message, right? Is that what it is? Because we printed the chunked message in decrypt. So as we're calling decrypt, so we printed. So this is the chunked. This is the decrypted message. This is what ChatGPT decrypted from the encrypted message. So it only undid the shifting, the shifting letter by letter, but the Unicode value thing. That's really interesting. Never print it. We should print the encrypted message. So we get to see what that looks like. There we go. There's some fun characters in here. Why not? Does that make a little bit more sense? Okay, cool. So I am going to cite my source here. I called it decrypt GPT, but I also wanted to include my prompt, right? That's what I asked you folks to do. So I'm going to include my prompt. So I can do a triple, how do I do it? What? Yeah, I thought it was, oh yeah, I can do triple quote, right, for a big message. There we go. So I'll leave this in. This was my GPT prompt, right? That's what I asked it here. right? You can't link back to these. Like you can come back to them, but there's no like URL you can go to, which is really nice. So the ChatGPT version from OpenAI you can link to now. Found out you can link those. But the UMISH one doesn't. But UMISH uses Model 4, which is supposed to be better than the 3.5, which is the free one with OpenAI and all sorts of things. And okay, sure, your mileage might vary. There's different tools and different fun things. All right. Well, we included our prompt for this one, right? We've cited our source, just like I've asked you to do. All right, so let me go commit that to GitHub for you. 501. Here was lab 3. All right. And that was playing with strings and string slicing, right? We sort of used that slicing notation for this, right? We didn't really use the slicing to undo. We only did it for the encrypt because that was fast. And you didn't really need to do the slicing, right? We could have done this with another loop inside of a loop, right? We could have done that, but the stride made this easier, right? Okay, so let's start up another chapter or another project here for what chapter number is that? Chapter 8. Oh, we're on chapter 8 already. Wow, we're flying, folks. This is chapter 8, lists. Now we've done lists already, right? We've done some list basics, right? So my list here, right? We have in square braces, right? We give it some numbers. 7, 8, 9. Sure. Here's some numbers. Oh, we should have some spaces. I love that it gets upset if you don't include spaces. Again, those are just warning lines. I just don't like when they show up because they bother me. So I'll try and make the warning lines go away. Python doesn't really care. It's just our IDE being helpful, right? And then I can say something like for value in my list, right? We can print value. We can loop through the list, right? Getting one value at a time. And when we looked at this, right, we looked at, can you change the value, right? Can I say value plus 10? And then when this is done, we print my list. Or when you do this sort of loop, are we changing the original list? No, we're getting a copy of the value. We're changing the copy. The original list doesn't change. If you want to change my list, you can say for index in range. I did it again. Range length of my list. And then I can take the my list at the index and add 10. Does this change the original list? Is this going to change the values in my list? Yes, because yes.
And then the one minus index that's accident that was the same thing.
So this changes the value in the list because it's saying list at this index, add 10 to your value. This one says the value copy that you have here, add 10 to the copy. So this will change the list. So this won't change the list. Values in the list. So doing this for loop gives you a copy of the values in it. Yeah. So changing the copy doesn't change the original. This is the original. This is the value at this location in that list. Go change it. I'm sorry? So when you just loop over values in list, you get copies. Here's a copy of the value. So value is copy of the value in the list, not the original. Right? When we look at where things are stored in memory, when we ask Python to give us a list, it stores a bunch of stuff in memory over here. When we do this loop for value in list, you get a new number in memory, right? You get a copy of it. Here's a new one. Here's a new one. Here's a new one. Here's a new one. We're working off that copy value. So we can loop through this way if you want to change the originals, right? If we print my list, we should be able to change it, right? Now they've all had added 10 to them, right? Didn't change and then did change. So just be careful what you're doing with the lists when you do that, right? If you want to copy them. Let's see, what else do we have? So lists, right? They're containers, they're mutable, we can add values. You can add different types of values. This gets really confusing. I don't recommend it. You can add strings and floats and other sort of nonsense. That gets really weird, right? You access stuff by index here, right? You makes a list. This is another way to make a list. People don't, it's not as common, I feel like, to do it this way. Some people do. So you might see list and then parentheses, they give it something. Right? This gets an index. You can slice lists just like you can slice strings. Go figure. That's why we talked about strings first. This slice notation works for lists too. Instead of just a single index, like you can get out of a string, you can get a list or a slice of, and what it does, it gives you a new list here. So you're getting a copy of it when we slice. So if I wanted to take the, I don't know, first or middle, I don't know, middle three values is my list slice. So I want from 3 to 6. So just like when we do slice notation on strings, we're going to start at index 3, go up to, but not including index 6. I'm going to get index 3, 4, and 5. And it's a copy of those. So print my middle 3 values. And I can even go change these ones. I can say for index in range, length of my middle 3 values, my middle 3 values at index about -10. We'll put them back here, print my middle 3 values, and then we'll print my list. What did I do? Oh, that's how I got insert. Numlock has to be on. Okay. There's like an extra one there. We'll print my my list. Okay. So once we slice here, so slicing makes a copy, right? Here's my middle 3 values that I got, right? I printed the middle 3 values. Then I subtracted 10 from them. I printed the middle 3 values, right? This way changes that list here, but it's a copy of the values here. It didn't change the originals of those middle 3 values, right? So because there's a copy, I can go and change the copy. It doesn't change the original from the original list. So some things when we do them, if you want to make a copy of a list here, so if you don't want to change your original list and you want to make a copy here, maybe we say this is a copy of my list can equal my list sliced. Remember, the start is defaults at the beginning, the end defaults at the end. So just colon here is slice the whole thing, right? Takes the slice from beginning to end. So now it's a copy because it made a copy of that here. So you can quickly copy a list using your slice notation. You'll see that often. If you don't want, it's like if you want to have a list you can mess with, you can do that sort of thing. You can set values. The delete is not as common. Some people use this. I don't find many people use this delete notation. Usually we use like remove when we're messing with lists. So you can make lists. Now, one thing you want to be careful of when we're looping through lists, we don't want to be removing things. It's going to get really weird. So if I make a list here, we'll go back to new list equals 1, 2, 3, 4, 5. And if we say for index in range, length of my list here, if we wanted to remove values, right? Did we look at removing things from lists? We said my new list remove, right? We looked at remove. All right, so how about we want to remove all the odd numbers and just have evens left? Can we try that? Okay, so let's remove all the even numbers. Let's have odd. So if the new list at the index mod 2 is equal to 0, if it's even, we'll take my new list, remove the new list at index. Right, remove the value. All right, let's try it that way. So let's see what we get. So let's print the new list. All right, so we're going to loop through the length of it. If we find an even number, remove it that even number. All right, let's just run that a little bit here. Oops, new list. That's spaces. What is it upside down? New list, print new list. Oh, range length of new list. There we go. That's what I was suggesting here. It's a nice hint. Uh-oh, list index out of range. We tried to get an index that didn't exist. When we got the length of new list, the length was 5, right? So let's put this in debug mode and run it in debug mode. I guess I just have to debug the whole thing. That's fine. All right. So here's our new list, right? 1, 2, 3, 4, 5. The range to the length of that. Now we're going to say, okay, is at index 0 even? No, it's not. Okay, so now I'll go to index 1. Is index 1 even? Is 2 even? Yes, it is. So let's remove it. We've removed it out of the list, right? Now we're at index 2. Okay, index 2, is that one even? Yes. Okay, remove it. Okay, now we're at index of 3. Is there an index 3 in my list now? No, there's no index 3 anymore because we've removed items. So because we ranged over the length at the beginning, that range got set at 0, 1, 2, 3, 4. So iterating and modifying a list as you iterate over it is no good here. So you shouldn't modify a list as you iterate over it, right? It will crash. That's no good. So let me just leave that commented out, I guess. We don't want that. So what you can do though is you can loop for index in range length of new list. We can loop through it this way. Can we even do that? No, we can't even do that because we don't want to be modifying it. So this is no good, right? This is not a good way to do this. So maybe we can say for value in my new list, but we don't want to be going off of each value in the new list, right? So we could say if value mod2 equal to 0, new list dot remove the value, right? And then we'll print the new list. Let's give that a run. Oops, print new list. Missing parentheses. Oh, that one worked so far. All right, let's try and remove the evens now. How about if it's not equal to 0? Or remove the odds. It doesn't equal 0. Cool, we got 2 and 4. That one seemed to work. Sure. So as we loop through each value, excuse me, in the new list, it seems to be working. But now let's change new list here. Let's go and add 5, 4, 3, 2, 1. We got an odd number. How do we get an odd number? I thought we removed all the odd numbers. All right, let's put a breakpoint in. Let's run in the debug mode. So as we loop through, the first time we hit this, value is 1. That's the first number, right? It's odd, so remove it. Now let's loop through and grab the next value. The next value is 3. What? 3? We skipped one. So when you loop over using a for value in list loop here, Python is tracking behind the scenes what index it was, essentially. It's not using the index, but it says, okay, I got the first number, give me the next number. As we removed things, everything shifted down into a new spot. So as it goes to grab that next value, there's a new number there that wasn't there before. So we've skipped over. So 3 is good, we're going to remove it, that's fine. 5 we're going to remove, right? But then the next 5 we skip over because now we have values 4 because everything got shifted down. It's no longer in that same place. So 4 we don't remove. The next value is going to be 3, right? 3 we do remove, cool. And then we skipped over 2, right? Now we're back to 1. So you can't, even with this notation, it's not safe. It looked like it was safe. It looked like it was doing the right thing, but it's not. So even this way, this one doesn't crash, but skips values as we iterate, right? So the right way to do it then is to loop over a copy of it. If you loop over a copy and if you change the original, you're good. right? Because we're going to get every value from the copy. So we can say for value in new list sliced. That's the copy, if it's even removed, right? Now we'll actually get rid of all the odd numbers because we're going to loop through every value that actually is there because we have a copy here and we're changing the original. So loop over a copy doesn't change as we change the original. Does that make sense? Why we would want to work with a copy as we change the original? All right, cool. So you just got to be careful when we're looping through them here. All right, some other cool things we can do with lists. We can append, we've done that. You can extend a list on another list. You can insert at a given index. I think we did insert before, right? Say, hey, I want this to become the new index 1 or the new index 2. You can remove an item by value. You can remove an item by index. Pop by index, or pop without an index removes the last one here. Other fun things you can do. You can sort a list. You can reverse a list. You can get the index of a value or the count of a value. I think we looked at those ones before too. All right, those are all the extra ones here.
How do you use the sort?
So if you call sort, so if I say new list dot sort and I print new list, it'll be sorted. So sort will modify the list and sort it in place. So it changes the form, it changes the order of your list here. So if the order matters, you probably don't want to sort it. But if you don't care what the order was, we can sort it, go for it. That's no problem. So I think I jumped ahead with this iteration here, right? Trying to iterate over range and length and max. Do we do max and mins? I think we did max and mins, right? Find the max number, find the minimum number. Okay. We did that one. Index error and enumerate. Enumerate is the way you can get the index and the value both at once. I think we looked at it real briefly here. This part's fun. So functions that iterate over lists, right? Max and min, we've used before, they actually have to look at every value in the list. So they will technically iterate over a list. Any and all is a little weird. Depends on what we're doing. They have some interesting cases here. So all says everything is true, right? This and this and this, it's anding everything together. And because Python is truthy, anything that's not zero is true, which is super weird. So if you have any zeros, I think is an empty string true or false? If print empty is true, else print. I don't remember here. It's false. Let's see what it is. I think empty strings are false. Yeah, empty strings are false. So nope, fail, false. So empty strings are false. Any string with any sort of value is going to be true. Any number that's not zero is true. So you'll see cases where this is fun later. We don't really do anything interesting with them. And then any says, is anything true? This or 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 this, right? It ors them all together, everything in the list here. And then some, we've done sums before. Oh, fun. List gains, max, min. Okay, sure. List nesting. Let's save nesting for next week. Is that okay? This is a list inside of a list. This gets to be really fun. It's like a two-dimensional list. Lists of lists. This will start to hurt our head. But we'll save this for Monday next week. Is that okay? All right, so we'll end a little early. How are things going with the Hangman game? Did you start on it? Cool. Started? Awesome. Cool. Right. That's next Wednesday. We're going to cover the solution for that, right? Okay. So if you got questions, let me know. I'm happy to get you unstuck. I'm not going to tell you to go away. I won't solve it for you like I do the labs until it's due, of course, but I'll get you pointed in the right direction. So this later tonight and then Thursday, Friday, I should be able to get caught up with grades. Sorry, I got behind there. Uh, Getting sick sucks. And then my wife got sick. So someone's always sick in my house. When you got 7 kids, there's like germs everywhere, which is awful. So, but it makes your immune system better, I guess, right? Is it true whatever doesn't kill you makes you stronger? I think it's only true in some cases. I don't think that's true for everything because, yeah. All right. So we'll pick it back up with nesting on Monday and we can go from there. Folks, have a good one.